Anyway, I'm Steve Renner, and I'm with the Colorado Division of Reclamation, Mining, and Safety, formerly the Division of Minerals and Geology, formerly Mine Land Reclamation. And within that bigger organization, I work for the Inactive Mines Reclamation Program. So I manage reclamation projects for our staff on the Western Slope. And I guess I had this great introduction all figured out, but really not happening. Anyway, I guess I just want to say thanks. I've been working in Coal Basin since when was it? It was 1994. I did the reclamation work up there, and we sort of substantially completed it in 2002. We have a whopping $1,700 left. I was joking with Bill earlier that we're probably either going to buy a bunch of seed or a bunch of beer. And I know which way I'm leaning. I'm open to suggestions. Anyway, what's really cool is that for years and years, and not to sound too self-serving, but we were the only people up there. And it's really cool to see so many people interested in this place. We sat through innumerable lawsuits and depositions and hand-wringing about what to do and how to do it and trying to figure out finances and how to make what little money we had available at any one time go as far as we could to deal with the environmental problems at the site. So I'm very grateful to see everyone here, and I'm grateful to see the interest that you all have in the site. But I just really need to point out a special debt of gratitude, I guess, to the CVPA, Dorothea, Bill, Mike Michaud, who's not here, John Stickney. These guys started bringing this site to the state's attention. Let me back up. The state had plenty of attention up here as a problem site during operations. But the local community was extremely vocal and anxious and very obnoxious, to be truthful, about their issues with the site. And without their support and help, constant nagging, especially Mike calling me at all hours of the day, going on and on about all the stuff he did or didn't see or did or didn't want to see. Truthfully, I don't know that we would have got off on the right start at the basin. And what's really great is over the years, not only has the restoration worked pretty well, but we developed some really great personal friendships and great relationships as a result of the interactions with the community. So anyway, thank you. And I'm very, yeah, whatever. So anyway, so I'm supposed to be doing the history, but you can't do history in Coal Basin without understanding the geology a little bit. And so very quickly, the Coal Basin, as many portions of the Grand Hogback, or this kind of ending limb of the Hogback, is bottomed by Mancus Shale. Same stuff you see in the Grand Valley. It's a deep sea, fine-grained late Cretaceous sediment, highly prone to erosion, hence the whole Grand Valley where I live, and also prone to significant erosion in Coal Basin. Overlying the Mancus is the Mesa Verde Formation, which is kind of intercoastal swamps and receding and intervening seaways that were responsible for the formation of the coal and the silts and sandstones that form the higher cliff faces in the area. Thank you. All of this was influenced by the Elk Mountain up batholith, I guess, laccolith. Any other geologists? So I can make stuff up. Let's call it uplift. Anyway, so the whole area was slightly metamorphosed by the whole Elk Mountain uplift action, which lended eventually to the really excellent coal resource up in there. Very, very high quality steel-making coal. Following the mountain building episodes, Coal Basin, as is most of the Intermountain West, is defined by periods of erosion. What defines, in my mind, the landform of Coal Basin is extensive erosion and mass wasting. Those are the factors that create Coal Basin and cause Coal Basin to be the dynamic and very energetic place that it is today. This is obviously evidenced by debris flows that you see in Dutch Creek. It's famous for its debris flows. You see the incision of the creeks, Dutch Creek, Coal Creek, and the North Fork of the various creeks, and the sediment-laden runoff in the area. And this photo is just a simple little summer rainstorm up in one of the forks at Dutch Creek. Basically more mud than water, but it's an incredible mud flow. It comes down, it hits Dutch Creek, and eventually comes down this way. But it happened only in one little isolated basin up there, which is very common in the area. This is a photo of the steep Mesa Verde cliffs up above Mine 5, the old Coal Basin town site area, just to give you an idea of how steep and severe the basin is at its upper extents near Huntsman's Ridge. I was standing at this site with, I was standing at Mine 3 looking north towards this cliff with somebody, a local, and he asked me to turn to me and said, "When was that mined?" I said, "Dude, that's what it is. It's never been mined. This is what the upper extents of the basin look like." So it's significant erosion. One day we were working up in the basin and we came ready to go home. I live in Junction. I was commuting up and down 100 miles each way for 7 years. Went to go home and this is blocking the road, just past Bradder's Trail. Like, bummer. You know, it happened in the course of 8 hours, a massive rockfall. Very dynamic place. We did this one. This is the mud flow. Very typical of summer rainstorms. That's actually Mancus Shale movement over more Mancus Shale into Dutch Creek. Thank you. And just the results of a minor summer thunderstorms. You can just see the mud-laden debris of Dutch Creek here at the confluence with Coal Creek. And you can just, simple shower, 20 minutes worth of storm activity up high leads to tremendous sedimentation that's very noticeable down below. This was an awesome event. This happened maybe 2 summers ago. It was a phenomenal, I wish I'd seen it. Anyway, this is the evidence of a massive debris flow in Dutch Creek. I'm sure, bless you, maybe 3 summers ago this coming summer. And what you're looking at here is extremely fine-grained Mancus Shale and Mesa Verde sandstone and shale derivative materials within the North Fork of Dutch Creek, or no, within Dutch Creek, right near the intersection of 3 Mine Road and 1 and 2 Mine Road and 4 Mine Road. And what you're looking at here is the remnants of this debris flow that flowed bank full. And you can see where the fine-grained sediment ends and you come back into the cobbles on the south side of the bank. And here on the north side of the bank, you can see the same evidence. You trace this downstream and you can see where the debris flow moved down Dutch Creek, finally lost energy, deflated, and the water escaped from the flow body itself. Last summer, Mark and maybe Mike Michaud and a few of us were up there near the 3 Mine Road and we saw evidence of a phenomenal flash flood that looked like that totally changed the dynamics of the channel on the road up to Mines 1 and 2. So I'm just trying to give you a flavor for the fact that this really, truly is a dynamic place. It's changing constantly and it impacts whatever you do down low or up high anywhere in the basin. Next, please. This stuff you already know, but since it's history, I got to do the history. So you know in the late 1800s, John Osgood developed the Coal Basin mine, what we now call the Mine 5 area, but the old Coal Basin town site, at the headwaters of Coal Creek. Those mines operated until 1908, and eventually they shut down. When they did do the development up there, though, they, of course, built the town, but there's also a pretty extensive mine working up there. And they left actually a large amount of coal refuse in the headwaters of Coal Creek, and we'll get to that in a moment. But the early operations were not benign in the basin as well. In 1956, Mid-Continent Coal and Coke began operations up there. They eventually established 5 underground mines over the course of about 10 years, and operations ceased in 1991. Each mine was at 10,000 foot elevation. As far as I can tell, easily the highest elevation coal mine in North America, if not the world. I don't know about that, but definitely way up there. Each mine had about 4 entries plus mine fan entries. The mine entries were developed basically on ridge lines. Anybody that's been up there has seen, well, I'm getting ahead of myself, I have photos. This is where I start wasting all my precious time. So anyway, to access all the sites which were located on the south, way in the south end of Dutch Creek, all the way up to the north end of the Coal Creek Basin, they developed a haul road system that's about 60 feet wide or so on average by 15 miles in length. That haul road system was substantially replaced in the mid-'80s by the development of the rock tunnel, and we'll be up at that site during the field trip today. Coal was cleaned at the site. There wasn't a very, there's a lot of sands and shales mixed in with coal. So ever since initial operations, the coal was clean, sandstone, shale, and other byproducts were washed out of the mine at the confluence of Coal and Dutch Creeks and deposited in 2 refuse piles. one appropriately named the old refuse pile, and the newer one called the sooty refuse pile. And we'll look at those today also. The mine-made water, I'm not sure I understand how the water was discharged prior to the construction of the rock tunnel, but after the rock tunnel was created, the mine water discharged from that tunnel and continues to do so today, and we'll take a look at that later. That discharge from the rock tunnel eventually led to big problems, environmental problems, which forced, I think, SEVIPA to get involved with the state regulatory process. In 1977, there was finally some national coal mine reclamation legislation was enacted. It allowed the states to regulate mines. Basically, the states implemented the federal law. In about '84, Mid-Continent Resources, then the operator of Coal Basin, received a permit from the state. Tremendous operational environmental issues, and for a lot of different reasons. And those issues generated numerous citizen complaints. So from the late 80s through the early 90s, there were tremendous amounts of attention at the site by the feds, by the state, so my counterparts in the regulatory world. The company obviously was responding to those pressures. Local public interest groups, my way of being politically correct, the SEVIPA and Soper's Greens, Tom Crumpacker was involved at raising awareness of the site. Definite stories unto themselves. You want to drink beer and talk about all the wrangling that went on, I'm pretty much available at 10 o'clock. Anyway, a story unto itself. The upshot of the whole thing is that, go ahead. Resources filed bankruptcy in '92. The state revoked their operating permit also in the summer of 1992. And as part of that revocation, they were ordered to complete the reclamation. And so they could not comply with that order. So in August of sometime in 1993, the state revoked their reclamation bond. And that's when we started. And at that point, then it becomes the people I work for, the Inactive Mines program's problem to take that bond and reclaim these abandoned or inactive mine sites. So we began reclamation work in the summer of 1994. So what are the environmental issues that drove reclamation planning up there? It's exactly the stuff that SEVIPA was bringing up in the early 90s. Primarily sedimentation from mining-related facilities, so the roads, the facilities area, which is the old wash and prep plant area at the confluence of Coal and Dutch Creeks, the mine bench outslopes, well, I'll show you photos of what I mean by that, and the refuse up at the Coal Basin town site. As well, there's all kinds of rumors and discussions about possible contaminants in the site. We did a contaminant survey. We did a level 2 environmental analysis of the site. The only thing we ever came up as far as contaminants was underground storage tanks that were left behind at the facilities area and resultant diesel-stained soils. Other issues included instability of the old refuse pile at the confluence of Coal and Dutch Creeks and the instability of the Dutch Creek diversion that was in place at the time. So this is the earliest photo I could find of the operations. So here you are, Coal Creek, Dutch Creek. Their confluence at that time was way down east of its current location. Dutch Creek cascaded, as far as I can tell, into Coal Creek pre-mining in a series of alluvial fans. Tremendous elevation difference between these two. At this location, I bet there's a 60-foot or better elevation difference. So it cascaded as far as I said through a series of alluvial fans in a migrating channel pattern. Anyway, so this photo I think is from the mid-'60s. Here's the prep plant, the haul road to mine 1 and 2, warehouse facilities, and a belt line. They're just starting to develop the refuse pile above Coal Creek. Next, please.
Is that up at the current parking area at the end of the road now?
Yes, yes. In fact, this is another good picture. Here's Redstone's off this way. The initial, that last photo I showed you, the belt line was just coming out here, and they're starting to stack refuse in this area. This photo was taken right before we came to work in 1993. So the coal prep plant, the coal storage silos, prep plant, prepared coal for trucking off the site was located here. Office, warehouses, this is where the buried diesel tanks were. Coal Creek by this time had been in its natural channel to this point. Previously, it just went back and forth in alluvial fan to cascade into Coal Creek. The mining company built a concrete channel called the Dutch Creek diversion, I guess. More or less a 12-foot wide by, I can't remember, 400, 600-foot long concrete channel with a big honking culvert at the end to dump Dutch Creek into Coal Creek. Next, please. This is the best I could do. It's a crappy photograph, but it's one of those timeline things off of Google Earth. Same period of time. This is up just west of the prep plant area. Here's the rock tunnel location. Here you see the overland conveyor system that conveyed the coal from the rock tunnel to the prep plant area. Road eventually goes up to Coal Basin or Mine 5. This road goes to Mine 3. And at this confluence, this road leads to Mines 1, 2, and 4. You can see the 1 and 2 road actually here in the background. Next, please. So just more again for reference, confluence of Dutch Creek and Coal Creek. The parking area is right here. The old refuse pile is here. The reconstructed Dutch Creek flows right adjacent to the parking area. Mine 4 is to the south. 1 and 2 are in the center of the basin. 1 drains to Dutch Creek. 2 drains to the North Fork at Dutch Creek. Mine 3, a little north of that, drains both to the North Fork, but primarily to Oil Well and Coal Creeks. And Mine 5 is the old Coal Creek town site. Next, please. So I wanted to just give you, how are we doing for time?
You got 15 minutes.
Perfect. Okay. So, am I going too fast? Is this working okay? Okay. So anyway, what I want to do is just give a sort of a photo tour of the environmental restoration or reclamation work we've done over the last, I don't know, I can't do that kind of math, 18 years? I think I had black hair when I started. Anyway, so I'm trying to address the primary issues that we identified when we went to work at this site. So starting with the road reclamation work. Next, please. So this photo is an aerial, obviously, of the road to mine number 4, the most southerly mine, right up above Dutch Creek. You can see the mine entries in this road that switchbacks back and forth. So it's there, 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 all the way up from Dutch Creek to the number 4 mine. And next, please. These haul roads, as I mentioned, were more or less 60 feet wide. There's 15 miles of them. And the purpose of the roads, obviously, was to transport coal from these loadout silos located at the entry areas down to the prep plant at the confluence of Coal and Dutch Creeks. So from any one mine, it's probably a 3 to 5 mile haul, from 10,000 feet down to, what's the confluence, maybe 8,300 feet. So it's a pretty good traverse up and down the hill. Next, please. The purpose of the roads, the design of the roads at that time was very practical for the most part. It was to facilitate these large haul trucks using those roads essentially, 365 days a year in all weather. The roads, this photo is not great, but the road system was designed to have a low point at this inside ditch, and then the road rises to the outside with an MSHA required berm. So all water that hits that road comes down across the road and into this interior ditch. The interior ditch then would drain water some distance down the road until it finally hit a culvert when they functioned. But you have a lot of traffic on the road, and periodically the whole ditch system would break down, maybe a big snow, maybe a rock fall, maybe you're just not keeping up maintenance. So periodically you just have drainage coming down the road and circumventing the interior ditch, adding to sediment and erosion problems. When the water finally did report to the ditch, it would hit a culvert. And culverts were sort of sporadic, in my opinion. They weren't placed nearly as close together as maybe they should have been. When they did discharge, they discharged a tremendous amount of water onto these Mancus Shale-derived side slopes and created phenomenal gullies. It was not uncommon. I think I have a picture of Mike Michaud standing inside a gully that's well over his head. So you could see gullies literally 6 to 12 feet in depth. At not every culvert, but at many, many of the culverts located up there. Next, please. Periodically, the culverts would fail. This is Oil Well Creek on the way to mine number 5. Periodically, because of debris flows primarily, culverts would fail and force the water to come up and over the road. In this case, taking out, I don't know, probably about 40 feet of a 60-foot road and taking all that dirt right back through Redstone and down the road. So our goal in reclamation was to try to reestablish, well, we had 2 goals. Number 1, try to reestablish to the extent we can the hydrologic regime of the area by allowing water from any one inflection on the hill slope to travel through the road prism in its natural inflection. So we want to bypass the whole ditch and culvert system and allow water to travel its natural path across the road prism and continue down towards whatever the receiving creek was. Also, we did not have the financial ability to completely backfill these roads, so we were only able to accomplish enough backfill to accomplish the goal of recreating the hydrologic regime at each road prism. Next, please. So the concept was to take this light equipment, and if the road, how do we do this? So I'm the road. And you have a cut slope and a road that's tilted up like this, and the ditch is right here. We want to take and turn that road prism so it's facing outwards like this, and allow water to come down the existing cut, across the reconstructed road slope, and on down the slope. So to do that, we just use simple equipment, a dozer and a track hoe, to take the outslope dirt, fill in that ditch, and then give some rise to that cut slope area so that we've reversed the gradient of the road prism. Thank you. So this sort of shows the cross section where previously this had been the high spot and this had been the low spot. Now we have the interior being the high spot and the exterior being the low spot. Next. Then, because I'm just super paranoid about water velocities, we went through and ripped the road extremely hard. And what we did was we ripped it at a 30-degree angle to the fall of the road. And some intense calculation I did at the time, the 30 was just right. I couldn't begin to tell you why anymore, but the 30-degree angle, to the fall of the road was the precise angle. So I'm out there with my little Brunton making sure the dozer operator is operating at 30 degrees, whatever. The important thing to note is you can see these rip lines coming like this. The road, although sloped from here to here, also falls from here to that dozer. So by having these rips, any water that comes across this and wants to flow at this angle, which is its natural inclination, has to hit one of these rip marks. And that does two things. Number one, water is going to hit those rips and start to infiltrate into that road surface, creating a pretty good situation for revegetation. And number two, you have zero velocity. If you have zero velocity, you have completely, I hate to say zero or completely, you've greatly reduced the potential for road erosion. So that was the goal of this project, and it was worked very successfully. Also, to accommodate the stream flows and the defined post-reclamation land use and non-motorized recreation, we built just a bunch of very standard rolled dips in the roadway. So every place, and we did this more successfully in later stages of reclamation than our initial stages of reclamation. Everywhere we had water coming from above to below, we'd establish one of these dips to allow water to traverse that reclaimed road slope. Next, please. And this is just an example of the revegetated road prism. Next. So the mine entry areas, as I mentioned, next please, we had five entry areas. This is a great photo from hard to know when, probably the late 70s, early 80s. But you can see this ridge line, and you can pretty much picture how the ridge line used to come across like this previous to any mining. So this is state-of-the-art mining technology in the 50s. I have no problem with that. This is how it was done. Hogged out a bunch of dirt, basically took that ridge line out, took that dirt, pushed it over the sides, it cascaded down those slopes, and at this area, so this creates a high wall or a tall, vertical face with the coal exposed at the base. You can drive your entries in that location right there. Same thing happened over here at mine 1. Is that true? This is mine 4, this is mine 1, 2. Sorry, details. Anyway, so when we came to the site, Mid-Continent Resources had removed all the metal from the site, and so we were left with the concrete foundations. So the goal of the reclamation is to try to reestablish to the extent we can the slopes in order to minimize erosive velocities of water from rainfall and snowmelt, and to establish a good base for vegetation, and to try to minimize erosion from the mining-related facilities. Next, please. Just a picture of a couple of the fan entries located on the sandstone crop up at mine number 1. Next, please. So this is essentially what we were able to accomplish, is that this had been this is mine 3, so maybe 150, 200 foot tall high wall. We put about 40 foot of backfill against the base of it. So we took all the concrete debris, all the structural remnants, put them into the mine entries, and then to accomplish our goals of trying to stabilize this site, whereas previously all the water that would drain from these mine entry areas. This is probably a few acres in size. Would come to various point discharges, so a point source of water leading off the bench down the road network or over this side to a wetlands down here. We tried to establish a more a broader sheet flow instead of a narrow point flow sort of environment. So to that end, we created a much flatter basin up here, but with a gradient that allows water to drain gently to the north and gently to the south, to the extent that anything could be gentle at 10,000 feet with really steep slopes. Next, please. So this is the mine number 1 loadout area when we came to work in '94. Next. And about 2 years after reclamation, same spot. Next, please. The primary, in my mind, the primary problem at the site existed at these mine outslopes right below the benches. Next, please. So when the benches were created, the mine face-ups were created, as I mentioned, all the dirt that came out of this ridgeline was hogged out, shot out, pushed out with a dozer. It was pushed out to the sides of these mountains. So down this slope here, you can see one here, Very characteristic dark shales and sandstones, some coaly materials. Angular repose plus, very unconsolidated, very susceptible to erosion and resulting in tremendous sediment loads to Coal Creek, Dutch Creek, and the North Fork of Dutch Creek. Next, please. This is the North Fork, north slope of mine number 3. This is 800 feet of slope length. Again, extraordinarily steep. And you can see the extreme rilling and gulling. Oh, okay, we're gonna really hurry now. Okay, extreme rilling and gulling occurring on these slopes. Next, please. We did not have, let's keep moving. We did not have the money to backfill those. So if in a great world with all kinds of money available, I would have picked all that dirt up and done something with it. But we didn't have that kind of money, so I never got past the something thing. So the thought was to try to revegetate these things in place in order to stabilize those slopes. Next. So the first initial steps was I took a bunch of seed and threw it out there, and these things develop a crust. So you can take a handful of seed, throw it out, and watch the seed bounce all the way to Coal Creek. So obviously we needed to scarify the surface. So we started by building little platforms and then putting a soil, what do you call this stuff? It's soil guard. It's like a soil stabilizing mixture, very, very expensive, like an organic glue essentially. Scarified the slopes, seeded it, and put this soil guard on top of it. Did well, but just couldn't afford to do it anywhere else. Next, we tried hydro seeding, and again had the same problems. We just could not reach the entire length of these slopes with the hydro seeder. Here you can see some of the little benches and shelves we created. Way too intensive. It just couldn't be done on the number of acres that we had up there to deal with this. So, next please. Next please. Actually had fairly good success, though, in the areas we could reach. This looks pretty good. It's about a 30% cover. Always take vegetation photos from the side. It looks so much better. We had maybe established a 30% cover, but that hydro seeder can only reach maybe a third of that 800-foot long slope. Next, please. We came in by hand and did some more work down below here, had some patches in between, but it went from a 0 cover to about this 30% cover. This is a north-facing slope, which is key. Next. But we had to scarify that by hand. So again, something that wasn't working really well labor-wise. So we invented this little machine, which is a 3-ton roller with little paddles on it. There's a cable that comes up hooked to a dozer. So as the dozer goes back and forth, this thing runs up and down the slope, creates little shells for seed to reside. Next, please. So here we are at the south side of mine number 3. Again, went from a 0 to 25 to 35% cover. Did a pretty good job, but you're limited by the amount of cable. So if this is an 800 feet slope, you need 800 feet of cable to make that thing work. So we moved on from that, using that concept. Next, please. We started using hand crews. Got just ahead of myself a little bit. The other problem we have is near surface soil creep, and that's contributing to sedimentation and erosion at the site. So to alleviate that, we planted bands of trees that are very successful on the south side of mine 3. So this is just the planting crew doing that work. Next, please, keep going. So what we did was, using that roller thing to scarify the slope, we came back in with hand crews using McLeod rakes, little firefighting rakes, to hand create all these little divots on the side of the slope. And we created, I don't know, 3,500 little divots per acre on these slopes. Next, please. And we came through, next please, and helicoptered in seed, mulch, fertilizer, next please. And went through the entire site and did that. We're, again, next please, we're pretty successful on the north-facing slopes and somewhat to the east-facing slopes. South-facing slopes, I wouldn't say failed miserably, but had a very difficult time. We also planted quite a few sediment barriers, natural shrub barriers at the toes of mines 3 and 5, I think, in order to try to trap whatever sediment we continued to generate off the site. I don't know if Andrea Hollandsears is still with the forest or not, but Andrea spent a tremendous amount of time with me up there. We did, all this work, the slope stabilization work, was covered by a non-point source or 319 grant. Forest Service was a partner with that, and Andrea did a tremendous amount of work helping me monitor the site for growth and for sediment accumulation and transport through the site, and just some of the simple ways we were measuring sediment transport. I think finally down to the confluence of Coal and Dutch Creeks. Next. This, just some before and after. So here's the Dutch Creek flume, here's the belt line, the confluence, the parking area is now right here. And that fence line on the private property runs right about where the silos are. Next, please. Who can forget the flume? It was anyway, engineering marvel. So about a 50-foot drop. Refuse on both sides. You can see it cutting into the refuse on both sides. Next, please. Sorry, it slides backwards. But when that started to fail, Mid-Continent put in this big culvert, which sort of exacerbated the problem of a lot of stream channel mechanics. The facilities area, previous to any reclamation after a snow melt, you can see the refuse was pretty much everywhere. Belt line going from the prep plant over to the old refuse pile. Next, please. So here we are following demolition work. The flume is still in place, as you can see. Here's the confluence. Parking area is now located here. Tremendous amount of concrete and debris everywhere. So that was probably in '94. This picture was taken likely in '97. The flume used to be located in this inflection right here. At that, in 90, this picture's probably 99 or thereabouts. We've reconstructed the Dutch Creek Channel over in its current location in '98, I believe. Next. Another before picture. And another after picture. Here's the old refuse pile. Mid-Continent did most of the work on the old refuse pile. I did the reclamation at the top. They did the bulk of this work over here. And the toe of the Sooty pile as well here. Facilities were right here, Dutch Creek right here, confluence, and the parking area now exists right here. Next, please. One more shot looking across the facilities area. This is where the diesel tanks were located that we dug out, and the old refuse pile. And the Dutch Creek diversion, the original one, is way back over here. Next, please. So this is where the Dutch Creek diversion used to exist. This is the reconstructed diversion and the reclaimed old refuse pile. This is just opposite the parking area, where inside the now fenced area. And that's the same area about 2 years following reclamation. There's about 50,000 cubic yards of concrete underneath this hill slope. So that fence, as you're looking to the east, the fence line runs something like this. So anyway, a lot of concrete buried under there. Refuse pile and other sediment control projects. Next. This is private property up at the old coal stockpiles on the way to the rock tunnel and post-reclamation. This is the old overland conveyor system belt line. Belt line going up to the old refuse pile, obviously pre-reclamation, the old refuse pile previous to reclamation. Next, please. And another one, pretty significantly impacted area during mining. And the same pile near the confluence of Dutch Creek and Coal Creek. We reclaimed the old refuse pile using abandoned mine land reclamation funds in the late 90s. Next, please. Same site after reclamation. Next, please. The Sooty pile, right before we started work, the belt lines existed up this direction and made a big turn and went up here, and refuse was deposited from the belt line terminus up on top. And then post-reclamation, this is the old location of the belt line right through here. Next, please. Various sediment control measures, including a lot of willow and tree planting. This is some willow wattles we planted up in Mine 3. We're pretty much there, huh? I'm done. Okay, good. Okay, and just looking at willow wattles, more willows and sediment control in road erosional features. Used a lot of high school kids to help with work, did weed control, both chemical and biologic. Reclamation partners, I have a handout later. We spent $3.934 million up at the site. This was all funded through the bond for the most part, subject to bankruptcy court, tremendous amount of legal proceedings. I hope I never see a courtroom again. This is what I wanted to sort of say is, I'm sorry, but so a lot of years, what do I know? I'm not sure. But I do know that if as work goes forward, we need to understand the environment of Coal Basin and work with its unique character. Otherwise, you're beating your head against the wall. Grazing, Wayne would probably shoot me, but I'm not a big proponent of grazing on reclaimed lands until you have a very well established and mature shrubs or vegetative stand. Microclimates, I think, are essential up there, and to work with the microclimates either that you build or that previously exist. If you don't disperse water, you're totally chumped up there. It's going to erode no matter what you do. And finally, I think in support of Scott's, hopefully, premise, is that I do find that soils and even remnant coal refuse is very amenable to revegetation with the addition of organic matter. And I think that's it.